Hi, this is Lakshmi Kantiwari. In this lesson, I am going to teach you about K-mean clustering in a Python. Okay, so first of all, I'll start with the K-mean clustering theory, and after that, I'll start what is the type of the clustering, and then which type of the clustering the K-mean uses. It uses centroid-based clustering, and then we will start working with an example. So we will work for two examples. The one example for data, which I have already uploaded on my the GitHub repository, the data.csv. There by default I have three clusters. Then I'll compare these three clusters with the predicted clusters. Then I would tell you that how you can choose right value of k, that means right value of the clusters. So these are the steps. I'll explain these steps, then I'll explain what is this elbow method, and after that I'll let you know that how you can select a right, how you can actually plot this elbow graph into k-mean clusters, and then how you can make sure that you should choose a correct number of clusters for your dataset. Then I'll start working with another dataset, which is iris dataset, and then finally I'll also show you how you can also make sure that your algorithm should make a right number of clusters. Okay, and apart from that, I have been already making so many other machine learning tutorials. If you have not watched my previous videos, you can go ahead on my channel KGP Talkie. There I have made so many other videos. Okay, you can watch those videos. Perfect. So without wasting your time, let's go ahead and start working with the k-mean clustering in a Python. Machine learning can broadly be classified into three types: supervised learning, unsupervised learning, and semi-supervised learning. So the clustering is an unsupervised learning technique. It is a task of grouping together a set of objects in a way that objects in the same clusters are more similar to each other than to objects in other clusters. So similarity, if you see here, the final clusters here is converged, the blue, red, and the green, right? So in these clusters, the similar objects in one cluster and the similar objects in another clusters, and here the same things is going on. So the moreover, what I can say here, similarity is an amount that reflects the strength of a relationship between the two data objects or two classes. So the clustering is mainly used for exploratory data mining, and it is used in many fields such as machine learning, pattern recognition, image analysis, information retrieval, bioinformatics, data compression, and computer graphics. So the moreover, the k-means algorithm identifies the k number of centroids. As in this example, you can see there are three number of centroids, or three classes. We are trying to get a three group from a given data points. Then after identifying the k number of centroids initially, then it allocates every data points to the nearest clusters, while keeping the centroid as small as possible, and the mean in the k-mean refers to the average of these data points that is finding the centroid. So the moreover, you can see these are the mean of these data points. Okay, so the mean distance comes here and here and here. So this is the three group, and it starts from the random selection of the data points, but after that it starts converging to a final data points. Okay, I'll take that later in this lesson. Now the question comes, what is the type of the clustering? So there are two types of the clustering: hard clustering and the soft clustering. In the hard clustering, each data objects or classes or point either belongs to a cluster completely or not. For example, here in above example, so the data points whether it belongs to this class or not. But in soft clustering, a data point can belong to more than one cluster with some probability or likelihood values. Okay, perfect. So although for this example these are the hard clustering, these are the not example of a soft clustering. But in the soft clustering, the data points could be also, let's say these data points could be also a part of this cluster as well as these clusters with some probability. Now let's go ahead and see what are the other type of the clustering algorithms. There are 4 types of the clustering algorithms: connectivity based clustering, centroid based clustering, distribution based clustering, and density based clustering. Now let's go ahead and first see what is the connectivity based clustering. So in connectivity based clustering, as you see here, the main idea behind this clustering is that the data points that are closer in the data space are more related than to the data points further, okay, like this. And the clusters are formed by connecting data points according to their distances. So this is the centroid of these clusters, and these data points are being connected with each other, okay. And the connection is known as a dendrogram, okay, which gives away why these are the commonly called a hierarchical clustering. So these methods do not produce a unique partitioning of the data, rather a hierarchy from which the user still needs to choose a appropriate clusters by choosing the label where they want to clusters. And another type of clustering is centroid based clustering. In a centroid based clustering, clusters are represented by central vectors or a centroid, okay. So these are the centroids, and this centroid might not be necessarily be a member of the data set, and this is an iterative clustering algorithm in which the notion of the similarity is derived by how close a data point is to the centroid of a cluster. So the K-mean is a centroid based clustering, and you will see this in this lesson, the more this centroid based clustering, okay. And another based of the clustering is distribution based clustering, and this clustering is very closely related to the statistics distribution modeling, okay. And data point in this cluster belongs to the same distribution, and the models have a strong theoretical foundation. However, they often suffer from overfitting. So in K-mean clustering, we don't use this distribution based clustering. In K-mean clustering, and in this lesson, we will be using a centroid based clustering technique. And apart from that, the final one is the density based methods, okay. In a density based method, it searches the data space for areas of varied density of the data points, okay. And clusters are defined as an area of high density within the data space compared to the region. So let's say here, so density is high here, higher density, higher density, higher density, okay. Perfect. Now let's go ahead and start working with the K-mean clustering, and we will be working here with the data set, and the data set is present on my GitHub repository. Go ahead and download it from Lakshmi Merit K-mean clustering in Python KGP Talkie crash course there. So we will be working with this data, and this is our working repository, okay, our working file. So let's go ahead and download this. And before downloading, I have already in fact downloaded, so I need to just read that data, and I need to first import necessary libraries to read that data.csv. So let's go ahead and first import pandas as pd, and then import numpy as np, and then import seaborn as SNS, and then import matplotlib.pyplot as plt. Now let's go ahead and it says that something, okay, some runtime error is coming there, not a problem, okay. So now let's go ahead and read the data. So the data is equal to pd.readcsv, okay. In a pd.readcsv, we need to give here the name of the data, so that is the data, and then we need to give here index call is 0, okay. Let's go ahead and visualize the head of the data, and in the head of the data you will get here x, y, and the cluster. So this is the data, the cluster is already given, although in a real world, in the practical example, you will not get a label data, since this is unsupervised learning. That's mean there would not be any output to test and get the accuracy and confusion matrix, all those things in K-mean clustering. Since this is an example tutorial, so I have already given the cluster, and we will be comparing our cluster with the algorithms and with the real value algorithm calculated clusters and actual clusters. Okay, so now let's go ahead and see how many clusters are there. To do that, we need to get here the data cluster. Okay, dot value counts. Okay, so here you will get here there are three cluster 0, 1 and the 2, and 0 and 1 is having 67 and the cluster 2 is having 66 points. Now let's go ahead and visualize this cluster in using a scatter plot using matplotlib. So the plt.scatter, and there we have let's say the data and x, and there we have also data and the y. Oops. And then we have a data, that's the C actually. We already have x and y. Now here we are going to get here the color, that's the C based on the clustering. Okay, perfect. And the C map, which I am going to use here, that's the way it is. Okay, so now here we get here the cluster there, and these are the three clusters. Okay, perfect. So now let's go ahead and start the clustering, and we will see how our algorithm can do this clustering. So first of all, we need to get our K-mean clustering algorithm from here, sklearn cluster, and then import K-means. Okay, and then from sklearn dot preprocessing import standard scaler. So now let's go ahead and read the data into the X. So in a X, so we have here X column, as well as here we have Y column, and the Y is, although in unsupervised learning we don't need label data, but for a comparison, so we will be using this final output Y as well. So first of all, if you see here X is not standardized or normalized data. We need to first standardize this, so we can do with the scalar is equal to standard scalar, and then X is equal to scalar dot fit transform. Okay, so in this we have here X. Perfect. Now you can see here we have gotten standardized X. Okay, perfect. Now let's go ahead and assign this X into the data points. So there we need to put here once again for X and Y, and there we have X. Okay, perfect. Now let's go ahead and get our the K-mean. Their K-mean is K-means. First of all, that we are going to get here cluster n is equal to the 2, and then random state I'm going to give here a 42, and then I'm going to fit it K-mean cluster fit X. Okay, now we have got we have already fitted here our the data, so it's the training is done. Now let's go ahead and do a scatter plot and see how this data is being clustered. Okay, So here we have a plt dot scatter. Okay, in fact I think we can do the same thing here. Just copy it and paste it here. Okay, perfect. So now you see here we have got here 3 data points, right? Actually the data is the same, x and the y, but here this cluster, a new cluster is being created by the k-mean. If you see here the k-mean dot labels, so it has generated just 2 clusters, 0 and the 1, right? And the centroid of the k-mean clusters also can be get by the cluster centers. So these are the two, only the 2 cluster, and the centroid is given there. That's mean in the C, the color bar, we need to pass here the k-mean dot label. Okay, so now you see here there are 2 clusters. So this is the one cluster, here is the another cluster. So this is how this the clustering algorithm classified this into the 2 clusters. Although our original cluster, if you see here, our original cluster look like this. Okay, now let's go ahead and see if we classify this into 3 clusters. So you can give here 3 result, and then now you see here the 3 cluster. Okay, and but you can also see here there is a small error. The original cluster, this data belongs to this cluster, but in the predicted cluster, this cluster is the data belongs to this cluster. I think there is just one point which is wrongly classified, which is wrongly clustered. Otherwise the clustering algorithm works pretty well for a 3 cluster. Okay, but the question comes here, and that's the very tricky question. How do you make sure that is it the data is containing a 3 cluster or 2 cluster or 4 cluster? That's mean, how do I choose right value of n clusters? Okay, so if we go ahead and if you choose here 5, then you will see here it has divided this cluster into 5, but by your naked eye you can see here there is 3 clusters, clearly 3 clusters. Okay, then the question comes, how would you make sure that n clusters is the precise as it is possible? Okay, so there is a technique for this one. Okay, and the technique is pretty simple here. Okay, let's go ahead first to delete few line. So the technique is pretty simple. Let's say assume we have data points x1, x2, x3 and x kind of. Then how it works, pick a random points as a cluster center called centroid, like this here you see here, and start your clustering. And in the meantime, what you need to do, you also need to calculate the mean square error. Okay, the sum of squared error, that is the SSE, sum of squared error. Okay, for every different values of the k, you need to calculate the SSE, sum of squared error. Okay, and as you increase the k, that is the clustering point, then your SSE, sum of squared error, start decreasing. But after a certain point, your sum of error, okay, stops decreasing, or its a slope is becomes very low. Okay, so this is known as elbow method. Okay, so in this we can identify that the 3 is perfect, although this is not the example of our data set, this is just a random example. But in this example you can find out that 3 is a kind of a perfect selection for a k. Okay, so now let's go ahead and work with this let's go ahead and find out the perfect k for our data set. Okay, perfect. So that is known as SSE. To do that, what we need to do, we need to create SSE is equal to first empty list, and then we are going to run our algorithm for k is equal to 1 to 9. So here index is equal to range, there 1 to 10. Okay, sorry, 1 to 10. And then I'm gonna use here a for loop for I in index, and then here we have K-means is equal to K-means. Then here we have n clusters is I, and then here we have random state is equal to 42. Then here we have K-means fit, and then here we have X, and then we are going to append into the SSA K-means. Okay, if you remember, the K-means dot inertia inertia gives the sum of squared error for a particular K. Okay, and let's go ahead and print that. Okay, and just run it. Now you see here we have got for K is equal to the 1, although I can run it with I like this. For 1 we have 400. For 2, if K is equal to the 2, it's 156, and if K is 3, then it's 44, and if K is 4, then it's 36. Now with this you can see here, if we choose K is equal to the 3, which is true in our case, in our data set, okay, in the true data set it's K is equal to the 3. Actually we had just a 3 data set, the 3 clusters. So in this case, okay, these 3 clusters, in this case we see our if we increase our number of clusters after the 3, now the error is not decreasing as it decreased previously. That's mean 1 to 2, 2 to 3. Now let's go ahead and plot this. How we can plot this? plt.plot. It's really very simple. Here we have an index, and then we have SSE. Okay, and then we have here plt dot x label, and in the x label we have here K, and then plt, then here we have y label, and in the y label we have SSE. Right, now you see here, so for 1, 2 and the 3, so this is kind of the elbow method here. Now with this we can identify that the 3 is a perfect choice for our cluster. So this is how it works. Okay, and since we already have our labels, now we can make a kind of the comparison, and of course the 3 is a correct answer in our this data this data set. Now one more thing I would like to tell you with the now let's go ahead and test it with another example with the iris data set. Okay, test it with iris data set. Okay, so let's go ahead first load the iris data set from sklearn, import datasets, and then we have here iris is equal to datasets, dataset dot load iris. Now let's go ahead and get the x is iris dot data. Now if I print here iris dot description, now you will see here it has a 3 classes, okay, and 4 input classes. That's the feature. So 4 feature space, 3 outputs, that's mean we should get a 3 cluster. Okay, so now let's go ahead and see if we get a kind of this elbow, okay, kind of this elbow graph at the k is equal to 3. Okay, perfect. So first of all we need to do the standardization with the scalar is equal to standard scalar. Now here we have x is equal to the scalar dot fit underscore transform, and then here we have x. Okay, perfect. Now x has been normalized, standardized. Now let's go ahead and create that elbow graph. So we can just copy it. Okay, let's go ahead and copy it and paste it here. So we already have X there, and just run it, and let's go ahead and plot it. Now you see here, so we get kind of the elbow here at the 3 are kind of 4, but on the 4 it is kind of the constant decreasing. So the moreover with this, we can also make sure that it can divide kind of into the 3 cluster, okay, which is the very true in our case. In the description, if you see here, it should be a 3 cluster, okay, iris, setosa, and versicolor and the virginic. Yeah, although this is unsupervised learning, therefore the error as comparison to a supervised learning would be more in unsupervised learning. Okay, perfect. So this is all about in this lesson. Please do not forget to subscribe this channel, and if you have any problem, please comment below. Bye bye, have a nice day.